Hello and welcome back. So in this segment we want to talk about the planet Venus. So the first thing that you're going to notice is that it's the same size as the Earth. Okay, now that's important because if it's the same size as the Earth, it should be as hot on the inside as the Earth, which it is. Okay, now inside the Earth, the heat is what generates plate tectonics. But we don't think that there's any plate tectonics on Venus. So something went wrong. And we'll find out what that is later. Another thing is it rotates backwards. So we think that this is a result of a collision. So the same type of collision that formed our moon, we think that something hit Venus and caused it either to flip completely upside down or to make it start to rotate backwards. So we're not quite sure as to which thing happened there. It rotates backwards, and one day takes 116 Earth days. So that means that when the sun comes up, it's up for a long time. And when the sun goes down, it's down for a long time. The atmosphere of Venus is composed of 99% carbon dioxide. And the pressure is great. So the pressure on Venus is 100 times the Earth pressure. So we say that the pressure of Earth's atmosphere is called 1 atmosphere. So the pressure on Venus would be 100 atmosphere. It's equivalent to the pressure that you would feel if you were down where the Titanic is located at. So if you were to step foot on planet Venus without a protective suit on, you would be squished, down to about the size of a soccer ball from the intense pressures. Then the temperatures. Now notice that the temperatures everywhere is about 453 degrees Celsius or 847 degrees Fahrenheit. So that would be the temperature whether you're at the equator or whether you're at the North Pole. So the temperature is pretty uniform everywhere on the surface of Venus. That is so hot that it would melt lead. So if we went back to, let's go back to Mercury and look at its temperature. So the temperature at its hottest is 801 degrees Fahrenheit, but on Venus it's 847. So Venus is the hottest place in the solar system. It has a runaway greenhouse effect. So we said that the greenhouse effect is that when light from the sun comes in, it can pass through the clouds because it's in the form of visible light and ultraviolet. So those kinds of light can penetrate the clouds. But then when they penetrate the clouds, they heat up the ground, and then the ground radiates that heat up into the air in the form of infrared light. And then that infrared light, as it tries to get out of the atmosphere, is blocked by those same clouds. So therefore the temperature rises. Now on Earth, what happens is that basically our atmosphere radiates heat into outer space at about the same rate that it is warmed up by the energy from the sun. But on Venus, the clouds are so thick that it can't keep up with it, and so the temperature has skyrocketed on Venus. Okay, Venus doesn't have oceans. We think at one time it did. The geology of Venus. So it has no plate tectonics, but it was resurfaced by volcanoes 500 million years ago. And it does have hot spots though. So it has areas where there is this hot material that's coming up to the surface, just like Hawaii, and so it's making those volcanoes. And as far as we know, it does not have a magnetic field. So let's see if we can explain why doesn't it have plate tectonics, and that goes with it doesn't have oceans. So the idea is that water in our oceans soaks into the rocks, and then rocks that contain lots of water are easier to melt. So that means that when those rocks are subducted inside the earth, because those rocks are saturated with water, they melt easier, and so then it's easier for plate tectonics to happen. On Venus, what happens is that those rocks are dried out. They weren't wetted down by the oceans, and so it takes a much higher temperature in order to melt that material. So therefore the plates on Venus are much thicker than the plates on Earth. And then that means that they're harder to bend, they're harder to pull apart, they're harder to push together, and so you don't have plate tectonics on Venus as a result of that. What does the surface look like? Well, the surface looks like a bunch of basalt and a lava plain. And so if you look at that picture that is right next to the picture of Venus, you will see that it looks like a lava field. And that picture was taken by the Russians. So whenever the Cold War began, the Russians decided that their space race would concentrate on Venus, and our space race would concentrate on Mars. So we know the most about Mars, the Russians know the most about Venus. Now the Russians, they got the bad end of the stick on this, because the probes that they would land on Venus would last for a couple of minutes before they would finally give out. Because think of what those probes would have to put up with. So temperatures in excess of 847 degrees Fahrenheit, enough that it would melt lead if you put it on the surface. Pressures that would be equivalent to the pressures deep, deep underwater. So their probes had to be built like tanks in order to withstand the pressures. Another problem with Venus is that sulfur dioxide in the atmosphere mixes with a little bit of moisture to make sulfuric acid. So you have to worry about acid baths on Venus. So it's a very inhospitable planet, and their probes had to be pretty tough in order to withstand this. So a little bit of trivia here for you. If you'll go to the internet and type in $6 Million Man, there used to be an old TV show back in the 1970s called The $6 Million Man. And in one of the episodes, he has to fight a Russian probe that makes it back to Earth. So the Russians brought back one of their probes. It went a little bit crazy. Nobody could stop it because it was built like a tank and could withstand extremes of heat and acid. But the $6 Million Man with his bionic arm and legs was able to stop it. It's fine quality American TV. So go ahead and watch that. All right, so that is Venus. And then later we're going to talk about the origin of Venus and then what happened to its oceans. So in our next segment, we are going to talk about the planet Mars. So I'll see you in just a moment.